Welcome back to another episode of Logic Unleashed, where we explore fascinating concepts from the world of computer science, mathematics, and logic. Today, we're diving into the intriguing realm of transcendental syntax. Now, I know that sounds like a mouthful, but trust me, it's going to be a fun ride. So, what exactly is transcendental syntax? At its core, it's a method for creating logical abstractions using a very basic, and can I say, logic-agnostic language. Think of it as building blocks. We start with something called stellar resolution. Imagine this as our foundational programming language, and we create what are known as constellations. You could visualize these constellations as programs made up of the simplest components possible. Now you might be wondering, what can you do with these constellations? Great question. They are used in a more advanced language called stelligin, which deals with concepts that you might be familiar with, like proofs and formulas. Essentially, it's a metaprogramming language that extends the use of these constellations into higher-level logic. Isn't that cool? It's like taking the Legos of logic and creating a whole universe of applications. The Transcendental Syntax project was initially introduced by Jean-Yves Girard and has since evolved, largely driven by Boris Eng in his PhD work. Let's take a step back and think about stellar resolution. This model of computation is not just any model. It's asynchronous and general, a logic-agnostic version of what's known in logic programming as Robinson's first-order resolution with disjunctive clauses. That might sound technical, but essentially it allows you to tackle problems in a flexible manner. Consider how this approach can be likened to how molecules interact in nature. Just like how molecules combine to create new substances, stellar resolution lets different logical expressions come together and interact, leading to engaging insights. It's like assembly language, but instead of assembling lines of code, we're assembling meaning. Now, transitioning to the learning aspect of transcendental syntax. The project is still in its developmental phase, which means features are evolving and changing, kind of like how a sapling grows into a tall tree. I encourage anyone interested to check out the Transcendental Syntax Guide /tsguide.refl./ though, fair warning, it's currently only available in French. But how can you get started? If you want to play around with it, you can either download a precompiled version or build it from source. If you're into coding, this could be a super fun project. There's even a section in Eng's thesis that discusses how to collaborate and compare models of computation, like Turing machines and push-down automata. All right, as we wrap up, let's reflect on some key points. Transcendental syntax provides a fascinating way to construct logical abstractions using stellar resolution and constellations. It opens up new avenues for programming and understanding computation. Before I sign off today, I'd love to leave you with this question. How might these concepts change the way we understand logic in the future? Keep pondering that, and maybe explore a bit more about stellar resolution and stelligin. Who knows what new insights you might uncover? Thanks for tuning in to Logic Unleashed. Until next time, keep questioning and exploring the boundaries of logic and computation.